Bismillahirrahmanirrahim. Now we're going to complete our revision of dynamics rectilinear motion. Here we have this example. In this figure, we have the relation between velocity and displacement or position for a body moves in a straight line. Find the corresponding figure from the figures below. We have here 4 different figures. It's required to find which one is corresponding to this one. The given one is we have the relation between v and x, and this is in a straight line like this. Okay, so we need to convert this curve, okay, relating v with x, and this is a relation between them. We have here 10 and 10. First, we need to convert this curve into one of these 4 given curves. Okay, if we check these given curves, we need to change the velocity in vertical axis to acceleration in corresponding one, and we need to change x here, displacement or position, to velocity. Okay, to change this one to this one, we have to substitute d dt. Okay, and here also to change x to v, we have to execute d dt, as we have a equals dv dt, and we have also v equals dx or ds dt. Okay, as well we need to find the equation of this curve and execute the first derivative with respect to time to find the figure in this required curve. Okay, first we need to find the equation of this curve, as we have at x equal 10, then we have v equals 10. It's clear that v equals x, this is the relation of this one, v equals x. Okay, to find the relation between a and v, we have to execute dtt for both sides. Okay, then we have here dv dt, and this is equal dx dt. Okay, from here we can conclude that dv dt equals acceleration and dx dt equals velocity. Then the curve here, the relation between a and v is a equals v. Then we can draw this one. Okay, this like this. Okay, here we have a equals v. Okay, the given one here is at a at v equals 10. We have a equals 10 as well. Then this curve is the required or the corresponding one to the given curve. I have another example. In this figure, we have the relation between velocity and displacement or position of a body moving in a straight line. It's required to find the corresponding acceleration displacement curve from one of the 4 given curves below. Here we have this curve relating between v and x over the time interval from 0 to 20, then from 200, then from 200 to 400. Here we have this one relating between a and v from the same time displacement interval. Okay, and for different curves, we need to select one corresponding to the given one. Okay, first we have to study the given curve. We have relation between v and x during the time interval from 0 to 200 x. Okay, we have here a relation between v and x. Okay, we can find this relation, okay, by find the equation of this straight line. Okay, here we have v equals ax plus constant c. Okay, as a is the slope of this straight line. Slope of this straight line is this distance divided by this distance. Okay, this is equals 40 over this one equals 200. Then we have 1 over 5, the slope of this straight line. Then v equals 1 over 5x plus c. At x equals 0, v equals 10. okay, x equals 0, v equals then c equals then add 1. Okay, this is the equation of this straight line representing the relation between v and x within the time interval is x interval from 0 to 0, 0. Okay, here we have to say that to change this one to acceleration, as we need to convert the vertical axis, okay, or y-axis to acceleration. Okay, we need to if we make first derivatives for all terms here with respect to x, for example, okay, here we have dv dx equals 1 over 5, okay, and we have a relation between a and v dv dx. Okay, then to find a we need to multiply both sides by v, then we have v, and we have here v, then a equals 1 over 5 times v. Okay, or in other words, a proportional to v. Okay, then a equals constant times v. Okay, we from 0 to 200 x unit. Okay, then we can draw this or sketch this one as follows: from 0 to 200 here x, as the given figures have x axis representing displacement or position. Here we have acceleration. Okay, here we can start with this start point and we end with this end point. Okay, then during this x interval from 0 to 200 we have linear relation, okay, straight line like this. Okay, this is first zone, x representing x or position or displacement of this moving body. Okay, from 200 to 400, okay, we have 200 to 400. The relation between v and x, okay, is constant here. Here equal v equals 50, 50, okay, unit. Then v here is constant. V is constant. If we dv dx equals 0, then acceleration equals 0. Then within the x interval from 200 to 400, we have here acceleration equals 0. Okay, then the corresponding curve to the given one is this one. Okay, and this is required to find. We have another example. In this given figure, we have the relation between velocity and displacement of a body moving in a straight line. Find the corresponding figure from the four given ones. Okay, then we have here four different given figures relating the acceleration of a body moving in a straight line with the displacement. Okay, which one is corresponding to this one? Okay, first we need to study the given figure. Here we have this one, the relation between v and x. Here when x equals 0 we have 2 meters per second. When x equals 2 meters per second we have v equals 0. First we need to find the relation between v and x by finding the equation of this straight line. Equation of straight line. Okay, here we have v equals negative x plus 2. Okay, as at v equals 0. Okay, we have x equals as v equals 0 we have x equals 2, and we when x equals 0 we have v equals 2. This is the relation or the equation of the straight line representing the relation between v and x. Okay, then we have to change this vertical axis to acceleration. We need to differentiate this equation with respect to time. Okay, in this time in this case we are going to differentiate with respect to time. For example, dv dt equals negative x, dx dt, and this is 0. Okay, dv dt represents the acceleration equals negative dx dt represents the velocity. Okay, a equals negative v. Okay, this is equation, for example, this is equation number 1 and this is equation number 2. Okay, here we can find the relation between a and x by substituting v equals negative x plus 2, then a equals x minus 2. From these two equations we find this one, the relation between acceleration and displacement of the given body. Okay, we can represent this as follows. Okay, here we have a and we have here x. Okay, at x equals 0 we have a equals negative 2. Okay, and of course the unit is meter per second square. Okay, at a equals 0 x equals 2. Okay, then we have here 2 meter, and this is a straight line representing the relation between a and x. Okay, then this curve is the corresponding one to this curve. Another example, we have here the relation between velocity and displacement of a body moves in a straight line. It's required to find the corresponding term from this given form. Okay, here we have first to study the relation between v and x and find how to convert this curve to acceleration displacement curve. Okay, the given one here is in this form. Here we have 4 meter x, here we have velocity 8 meter per second. Okay, first we need to find the equation of this straight line. Equation of straight line. Okay, here we have v equals mx plus c plus c. Okay, as m is the slope of this curve, the slope is this distance divided by this, but in negative direction. Then we have v equals negative 2 plus constant. Okay, 2x plus constant. When to find this constant, we'll substitute. When x equals 0 we have v, x equals 0, v equals 8, then the equation of this straight line equals negative 2x plus 8. Okay, this is the equation of this straight line representing the relation between velocity and displacement of this moving body. Okay, to find the acceleration of this body, we have two solution. We can here divided by we can execute first derivative with respect to t. Okay, for example here dv dt equals negative 2 dx dt, and this is equal 0. Then here we have acceleration equals negative 2v. Okay, this is equation number 1 and this is equation number 2. And here we can replace this v by this equation. Then we have a equals negative 2 times negative 2x plus 8. Then we have a equals 4 okay, x negative or minus 1/6. Okay, this is the relation of acceleration with respect to x. Okay, then we can sketch this curve. Here we have in vertical axis we have acceleration, on horizontal one we have x. Okay, here we have this negative acceleration. Okay, at x equals 0 we have a equals negative 16. Then we have here negative 16 meter per second square. Okay, at acceleration is 0 we have x equals 4. Then we have here 4 meter, and this is the corresponding curve to the given one. Okay, we can solve it in another technique. If we have v equals negative 2x plus 8, this is equation number 1. Okay, then we as we have a relation between a and v and x, v dv dx. Okay, dv dx is the slope. We have this relation or this given curve v and x. We have here this 4 meter and have 8 meter per second per second. Okay, We have acceleration equals velocity dv dx. dv dx is the slope of this curve. Okay, the slope here is this distance over this distance, or 8 over 4, but in negative sign, as the angle made by this straight line with horizontal x-axis is obtuse angle, then the slope is negative. Okay, then dv dx equals negative 8 over 4 equals negative 2. I have here a equals negative 2v. Okay, and also we can substitute from this one in this one, and we will find the final relation between a and x as follows: a equals 4x minus 16, okay, as before, and the corresponding curve to this equation is this one. We have an example here. During the time interval a and b, find the type of the motion for each given curve. Okay, here we have a curve relating between displacement and time t. During the time interval a and b, it's required to find the type of this motion. Okay, type of motion may be forward, okay, when v equals a positive quantity, or when v is negative, then we have backward the motion. Okay, if va is greater than 0 or positive, then we have accelerating motion. If va is less than 0, negative, then we have deceleration or decelerating motion. Okay, then for each given curve we need to find the sign of v and a, and multiply v and a to find the sign of this multiplication. First, for this first curve, we have a relation between x and t. This relation, in the time interval a and b, we have x equals constant value. Okay, then here we have here x equals constant value. Okay, then velocity equals 0 and acceleration also equals 0. Then in this case the body is stopped, is not moving. Okay, this is first curve. For second curve, we have a relation between x and t in this represented by this straight line within the time interval a and b. Okay, we need to find v first. V for time interval a and b. Okay, a is v velocity is positive. Okay, positive, as in this xt curve, the slope of the tangent to the curve, as in our example we have straight lines, in the slope of this straight line, okay, represented the sign of velocity. Okay, as the slope of this straight line is positive, as it make an acute angle with horizontal axis here, then v is positive as well. Okay, then the motion is in forward direction. This is step number 1. Step number 2, we have to find acceleration and sign of acceleration within the time interval a and b. Okay, as v here, v is constant, here is constant. Okay, then acceleration equals dv dt equals 0. Then here we have constant or fixed or constant motion in forward direction with constant velocity. Okay, you can express as follows. We have here a body moving in forward direction with constant velocity. Okay, this is curve number 2. Okay, here we have this curve also representing the relation between x and t. Okay, for time interval a and b, we have to find the sign of velocity first, as we have here a linear or straight line relation between x and t. The slope of this one is negative, as it make an obtuse, for example here, obtuse angle with the horizontal axis. Okay, here is theta. Then V is negative during the time interval A and B. Then the motion in backward direction. Okay, this is step number 1. We need to find A as we are dealing with X and T. Then acceleration here also equals 0 as V is fixed straight line. Okay, then here the body is moving in backward direction with fixed or constant velocity. Okay, this is for this curve. Okay, for fourth curve we have a relation between x and t in this curve during a and b, time interval a and b. Okay, we need to find the sign of velocity. Velocity here equals negative as the slope of this curve representing the relation between x and t, slope of this curve representing the velocity. Slope is negative as if we draw this straight line parallel to x axis. Okay, then we have here this obtuse angle made by this straight line and the tangent of this straight line with horizontal line. Then the slope is negative and consequently v velocity is negative as well. Then here the body is moving in backward direction, okay, or reverse direction. Secondly, we need to find the sign of acceleration during the time interval a and b. As v is constant, okay, then also a is 0. Okay, then the body in this case also moving in constant velocity but in backward direction. Okay, for last curve we need to find within a and b the sign of the velocity of this curve. Okay, if we draw during a and b in a horizontal line parallel to x lines, then we have here theta made by this straight line and its tangent to the horizontal within a and b is theta is acute. Then we have slope of this one is positive, then v is positive as well. Okay, then here the body is moving in forward direction. Okay, also as v is positive, then its derivative 2 time is 0. This is equals acceleration is 0, then the body is moving in forward direction with constant velocity.